All right, so let's continue our discussion about solving proportions, and this time in section 3.6, we're going to use cross products. I know that you've seen this before, but I want to make sure that we talk about it, how it's the same and how it differs, and when to use cross products, and when using our simplify methods from section 3.5 are easier. So cross product is talking about the product of the numerator of one ratio and the denominator of the other ratio. So we're talking about multiplying, right, product when we have two ratios that equal to one another. Whew. All right, so the second thing we're going to look at are scale drawings. Remember that the scale drawing is going to give you something like this. 1 inch is the same as 12 feet. Something where it happens in a picture compared to how it's going to happen in the real world. And the idea of a scale model, three-dimensional model of an object in which the dimensions of the model are in proportion to the dimensions of the object. So there's going to be a scale similar to this. And that scale is the relationship between the drawing's dimensions and the actual dimensions. Scale measure compared to actual measure is how we always write those. Now, example 1, plant food. To feed your plants, you need to mix 3 tablespoons of plant food with 16 ounces of water. If it takes 80 ounces of water to feed all of your plants, how many tablespoons of plant food are needed? So we're going to set these problems up the same way, organize, make sure that you keep your words organized. So it said 3 tablespoons, 3 tablespoons gets a capital T. For 16 ounces, we use OZ for ounces. And we want to know how much plant food to put in the 80 ounces of water that I have to use to water all of my plants. So here is my proportion. I'm going to set up 3 over 16 equal to x over 80. And here's where our new skill comes in. Yesterday, we said that we would go ahead and we would multiply by 80 on both sides. The alternate method is to recognize that there's an equal sign in the middle. And when there's an equal sign in the middle, we can multiply the means and the extremes. So the means are 16 times x because they're in the middle, and the extremes would be 3 times 80. Again, we're still staying balanced, so we end up with a left side. That's where I usually put my variable, but you don't have to. 16x is equal to 3 times 80, 240, and then simply divide both sides by 16. So that we end up with x is equal to, should be 15. Let me double check. I would do 24, that would give me 3 and 2, so 30 over 2 is 15. Yes. All right. Oh, but I didn't answer my question, did I? X equal to 15 is never enough when I have a story going on, right? What does my x represent? I didn't define my variable. Look at how important that step is. I would have missed a point because all I wrote was 15, when in fact this is actually 15 tablespoons. It's a pretty important difference. All right, example 2 is about scale model. An architect creates a scale model of a school. The actual school is 50 feet high. The ratio of the model to the actual school is 1 foot represents 75 feet. Estimate the height of the model. So they put actual height compared to model height. So the actual height is 50 feet. And we want to know how high that's going to be. And we're going to use the scale that 75 actual feet are going to be represented by 1 actual foot on the model. so that my proportion is 50 over x equals 75 over 1. Notice that this x is in the denominator. This is one of those places where using a cross product is almost the only way we have to get this problem done. So we're not going to divide both sides by 50. That's just not a pretty way to go about this. X is in the denominator, so I'm going to use cross products. X times 75, because I like my variable on the left. You can do it however you want to get 75x. 50 times 1 is 50. Divide both sides by 75 so that I get x is equal to 2/3 feet. Well, that's kind of awkward, isn't it? Could you change that over to inches? 2/3 foot is just fine, but 2/3 of a foot, there are 12 inches in a foot per 1 foot. So that, how many inches are in 2/3 of a foot? Oh, look at me building in an extra problem. How not nice is Mrs. Sturgeon? 12 times 2/3 equals 1x. Oh, let's see. 12 times 2/3. 4 times 2 is 8. So we end up with 8 inches. Obviously, the best answer is 2/3 of a foot, and I built in an extra question just to make you think a little harder. But that's where we're at with scale model. All right, here's a map scale. I'd like you to give this problem a try. After you've tried this one, come back because I want to talk about some of these algebra problems that don't have stories with them. So give that map scale problem a try. Hopefully that problem gave you no problems whatsoever, and you ended up with 347 kilometers. Let's move, though, to these algebra problems on the bottom. The first thing I want to point out is that whenever you see a sum or a difference, we've done this a lot, but make sure you put parentheses around it. It'll make your problem make more sense. Second, we'll put in that balance line, and the product of the means is equal to the product of the extremes, so we're allowed to multiply. And for the sake of my notes, I'm going to write this first step in two pieces, so that 42 times the quantity m plus 4 equals 6 times 77, so that 42, another 4, so 46. And once I get right here, then this is the point where it may make more sense to do distribution. Perhaps you prefer to divide by 42. I can tell you that I'm most comfortable, and the way that most students do these problems is to go ahead and distribute, because oftentimes we're going to have an m on both sides. But in this problem, it's not the only way to do it. So we end up with distributing 42 times m is 42m plus 168 equals 462. We're going to subtract the 168 from both sides, and then that leaves us with 42m is equal to 294. Divide both sides by 42. We're getting into some pretty big numbers here, aren't we? M is equal to 7. Let's double check. 14. Yep. M is equal to 7. So we notice the quantity decided to use cross multiplication so that 42 times the quantity m plus 4 was equal to 462. We did distribution, and then once that distribution happened, it was a two-step equation. When we go to do the next problem, however, it's not going to be a two-step equation after we distribute. It's going to be a variables on both sides problem. Get it started, see how far you can go. I'm pretty sure I know where you're going to get stumped, so get it started and then continue with the video. So give it a pause. Well, I hope I was wrong and I hope you were able to get further than this. But just in case, I did my cross multiplications, my cross product because there's an equal in the middle, and then I did my distributions, and now I'm ready to combine like terms. My 11x and my 3x need to get together first, so I need to add 11x on the right and on the left so that I end up with 8x minus 4.2 is equal to 55. I'm going to go ahead and add my 4.2 to both sides. And I end up with 8x equals 59.2. Divide both sides by 8. And I get x is equal to 7.4 as my final answer. Give that third problem a try. Pretty sure you should be okay with it, but try it out, come back and look at it. Excellent. I hope that you did well on problem number 3. Notice that I went back in and I numbered these just in case you needed to make one of your hot questions about something that you didn't understand in one of them. So I numbered them, and that way if you have a hot